Hello everyone, welcome to this lecture video. In this lecture video, we are going to continue the paging examples. What is paging? We discussed paging concepts of operating system in the previous video. In this video, we are going to see what is examples how paging is working. So in this example, we can able to see the logical memory and physical memory on page table. We could able to see the 0, 1, 2, 3 up to n numbers. We have the page tables and other values in the physical memory and logical memory. So free frames we having the before allocation and after allocation. In this paging new process, free frame list up to page 1, 0, 1, 2, 3 have the new process, and free frame list, and we having the page 1, 0 and n number of pages. So new process, page table, free frame list and other paging we can having in this allocation. So free frames we can have the this kind of screen new process page table working in this above format. So free frame list we have discussed what is frame, what is free frame list and others in the previous video. In this we go going to deep in the we have in the memory management system. We have the before allocation, the list will be in the described in the above picture. A denotes before allocation, and after allocation of the process, we have this kind of frame process. So for example, the new process page table 0 to 1, 2, 3. 0 will be having the 14, 13, 18 and 20 values that will be connected to the free frames. So this is about the things implementation of page. We can able to see next. We have discussed about the implementation of page table. So page table is kept in main memory. Page table base register is a point TPR points to the page table. Page table length register indicates size of the page table. In this scheme, every data or instruction access require two memory access, one for the page table and one for the data instruction. The two memory access problem can be solved by the use of special fast lookup hardware called cache and associated memory of translation look aside buffers. So TLBS. So implementation of page table, then associative memory. So in the associative memory we have the page and the frame. So address translation A and the other things we having the if A is associative register, get frame out. The otherwise the get frame from page table in the memory. Then page hardware with the TLB. So CPU in this picture we can able to see the connection of page table and other things. The page table will be connected to the TLB miss page frame number. The CPU connected to the PND with the address. P is nothing but the page number and frame number is second frame. So it will connected with the F and D. So physical address and will be connected to the physical memory. So this is about the things we are having in this process. So then effective access time we have the associated lookup and timeout. The assumed memory cycle time it is 1 microsecond. So hit ratio we having the percentage of times that page number is found in the associative register and relation related to the found number of associative registers. Then hit ratio equal to A and effective access time EAT equal to 1 plus A. The formula we given the effective access time. So effective access time can able to see in these things. Then memory protection. Memory protection we having the how the memory protection implemented by the associating protection bit with each frame. So valid invalid bit each attached to each entry into the page table. Valid indicates that the associated page in the process logical address spaces and is the legal pages. So invalid indicates that the page is not in the process logical address space. We can able to see the memory protection here. So invalid and invalid bit in a page transition. So we have the page 0, 1, 2 up to FI. The frame number we have the page table and other page and values. So valid and invalid bit in a page things. Page table structure having the hierarchical paging, hashed page tables and inverted page tables. So hierarchical paging we have the things we have in the structures hierarchically paging, hashed page tables and inverted page tables. So hierarchical page tables have the breakup logical address space into the multiple tables. A simple technique is a two-level page table. and other things. We have the logical is divided into a page number costing of 20 bits. Page offset consists of 12 bits. Since the base table is page, the page number is further divided into a 10-bit page number and 10-bit page offset. Thus a logical address as follows. So page number P1, P2 and a page offset having the things. So next, address translation scheme. In this address translation scheme, we have the outer page table and page of page table and other things. So P1, P2, we are having the address translation scheme for two levels of 32-bit paging architectures. So hash page table, we have the common address space with 32 bits and other things. So in this video, we have discussed the virtual page numbers or compared this chain. So paging and how the paging tables implemented in the operating system concepts. We had understand the few basic things of paging tables implementation in this lecture video. Thanks for watching. We can able to see the next upcoming topics in the next video. Thank you all.